Okay, in this problem, you're asked to find an antiderivative for this, which I've rewritten over here. This Desmos graph kind of proves that this is the answer. That's the antiderivative. If we take the derivative of that and the original integrand, there you get the same graph. So it looks like that's the answer, where C is the constant of integration. We're going to use integration by parts. That's a formula for integrating products of functions. So we do have a product, x times the sine squared of 2x. And a memory device for remembering, or at least your first attempt for choosing u, is Lie8 or Lipit. L for logarithmic, I for inverse trig, P for polynomial, or A for algebraic. And we're going to stop there because that's the first one that comes before trigonometric. So we're going to let u equal x and dv equal everything else and see what happens. So here we go. Here's the original, or the initial integration by parts. Let u equal x. So dv is the antiderivative of everything else. And du, of course, is just dx. Here's kind of a way to organize your work if you have to show your work. We're going to go to A to find the antiderivative of sine squared of 2x. We're going to use this identity, the cosine of twice an angle. It's cosine squared minus sine squared. If you replace cosine squared with 1 minus sine squared, you end up getting this. So for this identity, this 2 says that the parameter of sine squared has to be half of whatever this angle is. So if we have a 2 theta here, we need a 4 theta here. And what we're going to do is solve for sine squared of 2 theta, or 2x in this case. And this is what it looks like. And this is where we divide 2 into each term. So the antiderivative for sine squared 2x dx is this right here. And that's what v is in integration by parts. So using the integration by parts formula, here's u, here's v, u times v, minus the antiderivative of v du. Well, there's the v, there's the du. So we can break this integrand apart into 2 minus 1/2 the antiderivative of, I put the 1/2 out front, so x dx. Distribute this minus, this becomes a plus. The 1/8 out front, sine of 4x dx. The antiderivative of x dx, of course, is 1/2 x squared. So replacing this with 1/2 x squared gives us this term, plus 1/8 of, I went to b to find the antiderivative of sine of 4x. That's pretty straightforward. There's what it looks like. So that's what I replaced that integrand with. And now it's just algebraic simplification from there. 1/8 times negative 1/4 is negative 1/32. These two terms are similar. So 2/4 minus 1/4 is 1/4. There's your antiderivative right there. It might be helpful to actually go ahead and take the derivative of this to see that it actually does simplify to that integrand right there. There you go. Hope that helped. If you have any questions, post a comment.